Hello everyone. I am going to say about alert parsing. So slide 1, alert parsing is one of the most important techniques is the field of compiler design which focus on converting high-level programming language into machine understandable code. So in modern software development, compilers are responsible for analyzing and translating code efficiently, and parsing is a key stage in the process. Our LR parsing stand out because of its power, accuracy, and efficiency in handling complex programming language, because it is widely used in a real-world compiler. So construction tools such as YACC and Bison. So this topic explore how LR parsing works, why it is important, and how become it the backbone of modern compilers used in industries today. So now slide to the parsing problem. The parsing problem, any programming language, the source code written by developers must follow strict grammatically rules. Now as syntax. So the rule of parsing is to check whether the code follows this rule and to organize it into a structured format that the computer can understand. So the structure represented is called an abstract syntax tree, which is installed for further stage like optimizing and code generating. Parsing is not just about detecting errors, so it is also ensured that the meaning of the code is preserved correctly. Without a reliable parsing mechanism, compilers would fail into interpret code properly, leading in correct program execution or crashes. So now slide 3, inter-LR parsing. So inter-LR parsing is the type of bottom-up parsing technique. So that reads input from left to right and construct the rightmost derivation of the sentence in reverse. So it is known for its efficiency because it can process input line time, and meaning the time taken in case proportionally with the size of the input. LR pressure use a stack-based mechanism along with parsing tables to dedicate whether to shift input symbols or reduce them based on grammar rules. So this makes LR parsing highly cinematic and capable of handling a wide range of programming language. So now slide 4 is evaluation of LR parsing. So the evaluation of LR parsing is the first introduced by Donald Kuhn in 1965, marking a major breakthrough in compiler theory. However, early LR parsers were complex and difficult to implement. Later, Frank D. Rimmer developed a simplified version such as SLR, simple LR, and LALR, look ahead LR, which made LR parsing more partially and widely unusable. Now slide 5, prevailing consensus versus reality. So from many years, there was a belief among developers and researchers that automatic pressure generation, especially if using LR techniques, was too complicated for real-world programming language. So as a result, many companies preferred to use handwritten pressures, particularly recursive descent parsers, which were easy to understand but less powerful. Slide 6 is particle breakthroughs. So recent advances in LR parsing have made it even more efficient and partial. In 2022, Joy Zimmerman introduced improvements such as XLR parsing, which enhance traditional LR techniques by optimizing look-ahead handling and grammar transformation. These improvements allow parsers to handle more complex language with better performance. In some cases, automatically generated LR pressure have even outperformed handwritten parsers from languages like Go and Python. Now next seven slide is Hound parser. So Hound parser is significant advancement in parsing technology is the Hound parser developed by Scott MC Peak and Gures Nicola Hound uses a technique called generalized LR-GLR parsing, which extends LR parsing to handle ambiguous grammar. This is particularly useful for complex programming language like C++, where grammar rules can be difficult to interpret and been successfully used to create compact and efficient research for real world language. Now, its next slide is LR parsing in industry today. So LR parsing is widely used in industrial compiler construction due to its speed, accuracy, and robustness. Many modern programming languages rely on LR-based parsing techniques for syntax analysis. Tools like Bison and YACC are still commonly used to generate parsers automatically from grammar specifications. Parsers are capable to detecting syntax errors early or providing meaningful errors messages, which helps developers debug their code more easily. Their ability to handle large and complex grammars make them an essential component of modern software development. Now, second last nine slide is further of the future of parsing. The future of parsing is moving toward more interactive and intelligent systems. So, one important development is incremental parsing, where only the modified parts of the code are represented instead of the entire program. So, this is typically used in modern IDEs integrate development environments that provide real-time feedback as developers with code. Additionally, researchers are working on improving errors recovery techniques so that parsers can handle mistakes more graceful. Hybrid parsing methods that combine LR with other techniques are also being explored to achieve even better performance and flexibility. Now, last slide is conclusion. In conclusion, LR parsing has proven to a found, foundational technology in the field of compiler design. So, what started as a theoretical concept has evolved into a practical and widely used solution for parsing programming language. Is ability to handle complex grammars efficiently and accurately makes it indispensable in modern compilers. So, with continuous advancements and innovations, LR parsing is expected to remain a key component of programming language processing in the future. It truly deserves recognition and the engine that powers modern compilers. So the capable of detecting syntax error early and providing a meaningful error message which helps developers debug their code more easily. And their ability to handle large and complex grammars make them an essential component of modern software development. So with tools like the XLR and Ekhond LR parsing continues to drive innovation in software development, inspiring it relevance for decades to come. Thank you.